So I will go to the presentation. I'm going to talk about deployment pipelines in Spinnaker. We've been using Spinnaker for maybe 6 or 8 months now. And we have done so many pull requests and patches that we are actually rated as a contributor on Spinnaker. So I will tell you a little bit about what we've learned and what this tool is. In the beginning, I will go through some facts, a lot of slides, just defining pipelines and this stuff, and then we'll get into a demo where you can see stuff and ask questions and this stuff. So I hope you want to ask some questions. I'm a Norwegian, 33 years old. I have 3 children, and I work in the infrastructure platform delivery team in Schibsted. And I have a GitHub account and also a mail account. Yeah. And Keybase now, so yeah, it's quite awesome. In the team I'm working in, we are 4 people, 4 developers. So we are doing everything, like from writing cloud formation, setting up infrastructure stuff, and working in the application level, and doing on-call and support. We own 4 components in Schibsted. The first thing is the build service. That's handled by Travis. We run our own Travis on our own setup. We have the bake service, where we bake AMIs for AVS or Docker containers. And we have the storage service, and that's for storing artifacts like RPMs, debs, jar files, Python, gem files, whatever, and Docker containers. And we have the deliver responsibility, and that's deployments and pipelines and this stuff. So what is Spinnaker? Spinnaker is not only a deployment tool. It is also a platform for managing microservices in the cloud. That means you can get an overview about the runtime environment that your application is running in. So it's not just executing the tasks, it's also watching the infrastructure, and it lets you browse it and see stuff about your infrastructure. What's the cloud? We have one cloud here, and we have some other small clouds like the Google Cloud, AVS, and you have the on-premise kind of cloud, OpenStack, and you have Kubernetes, and Spinnaker also supports Azure, Cloud Foundry, and Titus. And Titus is a layer on top of Mesos that they're running in Netflix. So Spinnaker has bindings to all of these cloud providers, and you can add cloud providers to Spinnaker as well if you have some other cloud. So Spinnaker is a platform, and it consists of several services. So we have, in our setup, we have 8 of the services running. And there is more services, but these are the ones we are running. And this is Deck, is the front end. It's a thin web application just served by Apache. And Gate is the aggregated API in Spinnaker, and that's the only, you have the thin front end layer, and everything you do is talking with Gate that directs the calls to the other components within Spinnaker. ROSCO is the bakery, where you create Docker containers or AMIs, or you can also bake for OpenStack or Google Cloud. Igor is the CI integration. So Spinnaker currently integrates against Travis and Jenkins for CI. And it also integrates against GitHub and Stash. And that's done in Igor. And it's also, Igor also ships events on Docker events, Docker registry events. We have Front 50. That's a storage service. It's storing all your pipeline definitions and all your pipeline executions. Echo is an event bus, so it listens to events and emits events. Or it has an API to collect events and then it ships it. Orca is the orchestrator. So when you're executing something in your pipeline, the Orca is the one orchestrating, picking stuff from CI, running it out to the cloud or triggering a bake or whatever. Cloud Driver is the component that talks to all the various kinds of clouds and also Eureka and the console, I think, yeah. Yeah, it's true. So it seems kind of big with 8 services. Why are there so many services? That's because every service has its own responsibility. So when we started out using Spinnaker, we actually only used the bakery. We started with that several months before we started using the complete system. And because it has a well-known API and it's a separate service, we could launch this and use the bakery part without using any of the other components within Spinnaker. So that shows that you can opt into the various parts of it. And some people wonder if this requires a lot of resources. Because it seems big with the 8 services. But I have proof here that it can run on 2 Raspberry Pis. And that means you can probably run 8 Spinnaker clusters on your development machine. So it's not that resource heavy. So a common thing is people asking if it can replace the CI server, or if it's the same thing as a CI server, but it's not. It does not aim to run, execute builds and this kind of stuff. It will use the CI systems to run script tasks and Maven builds or whatever you have. And the various CI systems are good in this space. Where they are not so good is to trigger jobs and have dependencies and handle pipelines and this stuff. And they're not integrated against the various clouds. So why Spinnaker? As I said earlier, it integrates against various systems. So if you have if you have a CI system, you can integrate Spinnaker to that CI system that you're already using. And if you move to a different CI system, you can still use the same pipeline system. And it connects to the various clouds. So if you're moving from one AWS account to another or to Kubernetes from AWS or whatever, you can use the same pipeline system to do this and have the same experience across the various integrations. And there's a lot of things we gain by doing this, because when we have Spinnaker connected to all our AWS accounts, we can actually know what AMIs are running in every account. And if there is some sort of security threat, we have bake logs for all these AMIs, and we can see what the SSH version is running on every host, and we can search and find places we need to upgrade without logging into every machine. And it's easy to handle multiple runtime environments. Like I said earlier, running in Kubernetes, AWS, or whatever, it's easy to maintain in Spinnaker. So what's a pipeline? A pipeline usually consists of a build, CI build. Bake step, that's if you're running immutable infrastructure, you need this either to create a Docker container or a image to run in the cloud. But if you're not, you're usually running on immutable infrastructure. You might skip the bake stage, and then you deploy to the test environment, and then you run some tests against it, and you deploy to production. So I will get back to deployment. Yeah. Deployment. So what's the most important thing for a deployment? To me, it's the state of the deployment, that you know my application has started deploying, it's now deploying, and it's done deploying, and it failed, or it succeeded. That I know I can trace the entire deployment. Many times if you trigger a bash script that just runs it, you know that the deployment has started, but you don't actually know that it's successful or unsuccessful. And this is, to me, a very important part in the pipeline. And you need to trust this part. And when you deploy, you should be able to roll back no matter what. So you might have healthy instances, but you need to be able to roll back, and quite fast. You need to be able to deploy often, so that the changes you're deploying are only a few changes, not a big change set, so that you can actually trace what's going on when something's wrong. And it needs to be automated, and it needs to have no downtime. A build, that's for some languages, there's no compile step, but most languages you need to compile. Then you run unit tests to test that your code works okay. And then you can verify test coverage or verify the code styles. And then the important part is to upload the artifact to a central repository, so that you can fetch it whenever you want. A bake, this is to create a Docker container or AMI or cloud image. Yeah. So there's basically two kinds of deployments I will go through. One of them is the immutable infrastructure deployment, where you have a completely new image and you deploy that. Then you can deploy a new server group with this image running in, so that you have the old cluster running just as before, and you just launch new stuff that you start testing on and then put into load. And then you can turn off the load to the old version if the new version is working okay, and scale it down or delete it. Old school deployment works a little bit different, because then you have a given set of iron, maybe 20 servers, and you need to deploy to them while still running. So usually you remove some of the servers from load, and from the load balancer, and you deploy the code, and then you reinsert them to load and go through the other half. Yeah, this is done. So next step in the pipeline after deployment is integration tests. And it's very important when you have integration tests that you run them against actual deployed version of your application, and that you're not running it like in Maven. You can start Jetty and run tests against it, but that's not really the same thing as having a deployed version of the code to test against. So for integration tests, it's important that this is chained behind the deployment of that application, so that you actually know that you're testing the application as it would run in production. Performance tests, it's the same thing. Running performance tests within your build when you're starting the application in the build reactor is not the same thing as running it in the cluster that is production-like. Manual verification is just an ability I think it's important to have in a pipeline, that you can have as stop human kind of step, that you say that this is ready for production or not. If you have automated tests and everything is okay, it's okay to roll out automatically, but in many cases it's nice to have manual verification, at least when you're starting out with pipelines. So deployment to production is pretty much the same as deployment to test environments, but you can deploy to a subset of your users and instrument the applications and performance and see and have a slightly different rollout, a more data-driven rollout. So Spinnaker depends on Redis and the S3 or Cassandra to save your S3 and Cassandra is used to save the pipeline definitions and also the pipeline executions, while all the rest of the data is stored in Redis. So it's a live cache kind of thing. Yeah, we've gone through this. So I thought I would show you guys a little bit about how Spinnaker actually looks and feels when we're using it. Okay, so this is the pipeline view for an application. This is Spinnaker Igor. This is the application that integrates against Travis or Jenkins and the various GitHub and Stash stuff. This list here is a list of executions of this pipeline. You can see here that it's triggered build. That means that this pipeline has been triggered by a build in the CI system. If we press the link here, we get into the concrete build in the Travis that triggered the pipeline. So at the end of this build, we are uploading a Debian package. This is maybe a little bit small. This Debian package is uploaded, and when this pipeline is being triggered, it picks the Debian packages uploaded in the build and uses those concrete versions when it's doing the bake. So the bake here will bake an AMI using the artifact uploaded in the CI build. So when a bake runs, we have we watch it in Spinnaker. It will be blue while it's running, and red if it's a bad bake, and green if it's a green bake, successful bake. And this AMI we created here will be forwarded to the deployment stage. So when we do a deployment, this is a red-black deployment. It's the same as blue-green, but only in Spinnaker language. Here we can see the various steps. So what happens when we deploy is that we launch a new autoscaling group in AVS, and we follow this. It determines the source server group. It eventually starts launching or creating the new server group, and then it follows that the instances gets healthy before it moves on. So in this view, we can follow the actual deployment as it happens. It's not like I'm deploying and I'm done and it was good. We can see the details about the actual deployment. And that's very handy when it goes wrong, because you can see why did the deployment go bad. When we look at the pipeline, I think I will show you another pipeline that is a little bit more exciting to look at the configuration on. And Antonio is here, so it's the best pipeline to look at for. So this pipeline has the same start. It's got a configuration where it listens to a Travis job. It has a bake, and it deploys to dev. But what happens here is that it's fanning out to 3 different tasks at once. One is manual judgment. Is this ready for production? So if I run this pipeline and I just press, yes, it's ready for production, this won't be deployed to production before the Docker bake tests are green, and the AMI bake test is green. So we can go from 1 to many and back to 1 line again in the pipeline. And this is quite powerful, and it's quite easy to set up. I can show you how it looks. If I wanted to start deploying this to Kubernetes, for instance, I could just create a new bake, select Docker, say it's trusty, this, add the stage. I would maybe name this Docker. Oh, this stage is a deployment. Add server group, Kubernetes. Now I don't have a server group from before, but then I now I suddenly have 2 roads for this pipeline, and I could just set this one to be dependent on the deploy, and in order to deploy to dev, it had to work all the way here. Manual judgment. Yeah. So this pipeline now would bake an AMI while baking and deploying to Kubernetes, and these are requirements before it could deploy to dev. So you can play around and compose pipelines very easily in Spinnaker. These tests are running tests in the CI system, and they are triggering a separate pipeline for running these tests. And so this stage is actually a pipeline triggered within the pipeline. And this sub pipeline, or what it's called, is running the jobs in Travis, using the CI to run actual tests against the deployed code. Okay, so now I think I've shown you a little bit about the rich configuration of pipelines. So you can see that it's quite free within Spinnaker to create your own flows, and you're unable to run tests when you wanted, and you can set the requirements for deploying to production and such. So let's look at the other part of Spinnaker, and that's the part where you manage your cloud. Because when you're using Spinnaker to deploy and bake and all the things, you can look at your clusters that are running in the various accounts, and I'll just and then you have all the information about the cluster that is running. You can see it was created the 27th of October. This is today. It's running in US. It's healthy. It's got one instance, instance type, and so on. And you can see what package and what Travis built that actually produced the artifact that is running in production. So if I go here, I can see the log for the build in Travis that produced the AMI that I'm running in production. And that's quite powerful if you're debugging stuff and you don't know actually what's running there. You have all the metadata inside the cluster management part of Spinnaker to go and search for what's going on. And also, if you have like a flaky instance or some strange thing going on in one instance, you can find data like the IP addresses and shut it down from the ELB or remove it from service discovery and this stuff. So it enables you to work with your infrastructure and look at your infrastructure within the same system that you're using for handling the pipelines and deployments. Yes. Are there any questions about this? Anything you want to see here? Yes?
Is there any way to configure this flow via source control in source control manner? Or you have to build the UI hours?
Yeah. I will show you a little bit. You can do it now. The pipeline is represented as JSON already, but it's quite a lot of JSON. So we are currently working on a Kubernetes setup in Schibsted. And what I think we'll try to do here with pipeline as code is that in Kubernetes you can have it's a lot of fields to fill, but a lot of them will be common. So we could define some kind of generator that has simple steps and then generates this JSON. And also in the roadmap for Spinnaker now, there is Git-backed pipeline storage. That means basically that you have it as code. And yeah, so there is a lot of things going on in that space, but you could just push to the API this JSON right now. But that would be kind of something you create yourself. But everything is APIs, so you're free to do it, but it's a little bit hard right now, I think. And there is some third parties that has created this service that does this for you. You have all the pipelines defined in one repository, I think, and then it works. Yes. Was there another question? Yeah.
So you build the Kubernetes cluster after the pipeline. Like when you deploy, you build a Kubernetes cluster, or you push to.
The Kubernetes cluster will be running. Some other team or in infrastructure will create a Kubernetes cluster, and we connect Spinnaker to this using the cloud driver. And we only, if you set up a pipeline, you control the applications you're running on top of Kubernetes.
Yeah. So Kubernetes doesn't run on Spinnaker itself.
No. It's Spinnaker just talks to the APIs. Yeah. Yes.
In an earlier slide, you said that the integration test targets the system that you are building. Is there any, introspection or whatever? Is just arbitrary definition of what tests are influenced by what component that the programmer just?
Yeah, that's why I can show you this. I said that in this application I run the integration tests as a separate pipeline, and that's because we have two tracks to deploy to our test environment. We have one for feature branches and one for master, like the production pipeline. So both the feature branch deploy tests runs the integration tests, and also the the master pipeline. Yeah. So it's probably easy to just create a demo of this. I'll do it in Deb. So, new pipeline, my tests. So, in this pipeline, we can say that we run the wait stage. We say, this is my tests. And this could be a CI job, right? So this sleeps for 5 seconds, and then we could create a new pipeline that is my service, and this of course deploy, add stage, and then we execute. After deployment, we execute the my tests pipeline, right? And then you have yet another pipeline that is the dependency you have or something, lower service that my service is talking to. And if I have the dependency pipeline, I would just do like this and trigger the tests. So now, if I have a lot of things here, this is so I have my service. If I execute this pipeline, of course, my test needs to run. So here it will probably take 5 seconds to deploy this application, and then it should trigger my tests. Five. Then it should trigger my tests. So this is probably running, it's just waiting in background. This should complete in some seconds. Yeah, this has run, and it was green. So this is the usual kind of thing. I changed my service and my tests are run. That's no big deal. But when you have the dependency, the underlying service or a service from another team or whatever, you can tell them to run your tests on deploys as well. And then they suddenly run your tests while they're deploying new stuff. And then you get early feedback on errors coming from teams that are not your own dependent services. And I think this is very powerful, and this shows how you could just set up tests that actually makes you safer while doing it. If you wanted to solve this in a regular use case, you would probably be doing cron jobs, running tests every hour or so. But here you can actually do it and correlate it to an actual deployment of service you're dependent of. Because you can see here, or maybe you can't see this, But you can see that my test, this is triggered by the dependency pipeline, and this is from my service pipeline. And if this was read, I would know that something happened in this pipeline that made my test fail. So it's traceable.
If I get you right, the nodes of your dependency graph are pipelines. So basically you express every dependency as a pipeline, and then you concatenate them.
It depends. In this case, if you have a set of tests that are integration tests, you could define it as a separate pipeline so that others could run your tests, and that's useful if you're highly dependent on some other service. Yeah. Yes. Are there any more questions about this? Yes.
Just to be clear, so you can sort of define your own launch configurations with Spinnaker too. You need to find those in AWS.
Yeah, you can do it in Spinnaker. You can create auto-scaling groups, and you can create load balancers and security groups and this stuff. And there's also a flag in Spinnaker to disable this feature. So you can choose whether you want to expose this for your users or not. We recommend to just use Spinnaker to deploy your applications while you're using CloudFormations or Terraform or something like that to actually build your infrastructure.
But you can do it.
Yes. Okay. If there's no more questions here, I will just continue with the presentation. Is there many AWS users here? Okay. So I will go quickly through the bakery part of Spinnaker. This is the ROSCO component, and it has an API. And the API is quite simple. You can choose what base AMI to bake upon. And this can be, you can define it as a concrete AMI ID, or you can use one of the base AMIs provided in the endpoint. So Ubuntu or Amazon Linux is provided there. And the interface to do stuff with those AMIs is just a list of packages you want to install. So you have a list, you choose what to bake, what kind of AMI to bake upon, and then you give a list of Debian packages or RPMs, and that's the only things you have to say about creating your instances. And this sounds pretty crazy for me, at least, or it sounded crazy for me when I was coming from Puppet and Ansible and this stuff to create very rich AMIs, and suddenly I could just provide a Debian package or a RPM, and that seems quite strange. But actually, it's very powerful because it showed me at least how little you actually need to run your application and how simple it can be, because there is really not much to it. It's like for a Java application in our case, we need logging, centralized metrics, the Java runtime, and the application itself. It's only 4 things, but I've seen a lot of Puppet code to do those 4 things, and it gets cleaner with this simple API. So what's the powers of using an API like this instead of using Packer directly? You can, if you have instances running as a bakery, you always have them up and running. So there's no need to launch a new instance to do the bake. So in our case, we are using the CH root bakery part, and that just mounts the snapshot from AWS, and it installs your packages on top of that, and then it creates a new snapshot that is your AMI. And that goes a lot faster because you're not booting the new instance, and you shave off a lot of time by doing that. We also have like layered bakes, and that means that we can have a base AMI where we have the JDK installed, we have the logging installed, and we have the metrics collection installed. And then we only install our application on top of this. So the bake is only installing one package. It's not setting up the entire machine. And that shaves off quite some time on the bakery part. Oh. And we have incremental bakes. Means you're just running apt-get upgrade on the machine you already have there. So it only updates the packages that requires updates. So from our findings, it's like this is not entirely true anymore. But it takes an EBS bake usually uses about twice the time of a regular CH root bake. So the numbers here are a little bit wrong. I think we have about 4 minutes for CH root bakes, and I think it's about 8 minutes for a EBS bake. So we've added Docker support or improved the Docker support in the bakery in Spinnaker. And that's because if you're moving from AVS to Kubernetes, it would be nice to have the same flow as you go, so you can deploy to both Kubernetes and AVS in parallel and don't do too many changes at the same time. So I think in time, when we are going to move runtime environments, we will be able to do that using the bakery and bake both the AMI and the Docker container in parallel. And I think many of our users will go over to just create the Docker container in the CI system. But it's nice to have this smooth kind of transition way to go over to Docker-based runtimes. So we've talked a lot about the capabilities of the orchestration, but I've not gone into details about deployment strategies. I think I'll just quickly show how the deployment configuration looks. So this is where you set up the deployments. There's a lot of fields, but one important part is this one, where you have the strategy. So you can choose Highlander to only have one thing. And the one we usually use is Redback, and you can have custom strategies. That means you can create your own strategies as pipelines, and it will show up here as one of the strategies you can choose. What we do here is we can select. I think these two are quite important. It's the first one is that when you have deployed the new server group, are you going to scale down the instances to 0 instances? That means that the old cluster will be empty. So if you roll back, you need to launch or scale up the cluster before you can roll back. So for this application, we are not scaling it down, but for some of them, we are doing this. But if you don't scale down, the old version will not get traffic, but it will be very fast to roll back. It's basically, if you're using load balancers, it's the time it takes to insert instances to the load balancer that is your rollback time. And this is how many server groups you want to leave. So how many versions of my application do I want to have running so that I can roll back? And that's like, if you have 4, you can roll back 4 versions of your applications very fast. Then you can select the instance type and a lot of settings.
Small question.
Yep.
So here we're talking about instances, Amazon instances. But if we're talking about Kubernetes, we're talking about pods.
Yeah, I can show you Kubernetes. This is not the one. Yeah. So in Kubernetes, there's a lot fewer capabilities. This is all. I meant that it was more settings here. Oh yeah, I think I need to show you that afterwards. But the point is that this form looks completely different. So it's like tailored for Kubernetes. It's not the same things. In AWS, there's a lot of concepts, while in Kubernetes, there's a smaller subset. Yes. Whoa. So I should show you this as well. So in in the UI, you have project dashboard where you can have like all your pipelines and everything connected to your team or your project. And I will describe how these things go down to the various autoscaling groups and such. So you have a project that's your top level project. In my team, we have Spinnaker as a top level project with the different applications are the different Spinnaker applications. And every application can have several clusters. And a cluster is maybe running in Europe and one in US. So one application can run in several clusters. And within these clusters, you can have several versions of your application. So going from a project, there's quite a few steps down to the concrete instances, because instances is actually below the service groups again, server groups. So there is many layers. So if you're looking at an instance, you would be here. If you're looking at the pipeline, you would be here in the application. Yeah. So this is the relationships inside Spinnaker. Yes. Yeah. So one server group is one version of your service. One cluster is one or more server groups. It's like I told you earlier. It can be in EU West or US West, and it can contain several versions of your application. Application groups. It can have several clusters, and one application can consist of one or more services. And projects are one or more application group. So it should scale to many teams and many applications and services. So the Spinnaker experience so far for us has been setting it up. It's been quite a long journey actually to set it up properly. So getting the bakery up was one job, and then rolling it out to the organization and understanding the entire setup. It takes a little while. We've been running it for 6 or 8 months now, and we have not had many issues with it. We have some quirks now and then, but we haven't had any big ones, I think. When internet was down last Friday, Spinnaker also went down a little bit, of course, but it auto-recovered, so it was a nice experience. We've been contributing quite a lot to the project upstream, and that's been a nice experience. The guys in the central Spinnaker team are quite fast and responsive on PRs and questions. The support is actually better than some of the other support channels I've used. When I ask in the public Slack channel for Spinnaker about issues and stuff like that, people jump in very fast, and you get like the core developers to respond quite quick. So it's you learn stuff quickly and you get fast answers. Yes. So it feels good to be working with Spinnaker. Yeah, it's like any other service. The strange part is the configuration. They're using YAML in the configuration, and they're using it in quite a inheritance-based way. So if you're going to set up Spinnaker, you should try to learn or read the configuration, the YAML files in the config directory a little bit first, because there's like this eureka moment there where you see why why things work. Yeah. So you can get the code and documentation on spinnaker.io. They have a Slack channel. You can ask questions on Stack Overflow, or you can post GitHub issues when you're working with Spinnaker. So there's many interaction points. So I hope you've seen that Spinnaker is a platform for continuous delivery of microservices in the cloud. That is more than just deployments as well. It helps you get an overview of the runtime environment for your applications. Thank you. And is there any more questions? Yes?
So do you use Spinnaker to deploy and other more like infrastructure applications? Things that you would normally not have in an elastic auto-scaling group or something?
Yes, excellent question. The best example we have is Travis, actually, because how does Travis or CI systems differ from regular applications? CI systems are very stateful. So we have tasks in the CI system that can run for like 2 hours. So we use Spinnaker deployments in combination with the Eureka integration in Spinnaker, so that when you replace the Travis workers, it will launch the new ones, wait for them to come up, and when it shuts down the old ones, it will wait until the instances shut down by themselves, using Eureka to tell them that they should not pick tasks from the job, from the queue. And then when they've finished all the running jobs, they will shut down and the deployment will be complete. So a deployment of Travis workers can take like 1 hour. It depends on the slowest build that is running. Was that the kind of?
Yeah, that was kind of what I was thinking.
Yeah, and we have one more example is like you have some services that might have to run all alone, right? They can't be two, and that's quite simple to set up as well. So these kind of strange workflows that is not the common stateless application deploys works nicely as well, because it has a rich interface and you can choose and create your own strategies and this stuff. Yes?
Can you go back just one slide? The definition.
Yeah.
Where's the definition of
Spinnaker.
Spinnaker? Yeah. Where the definition, like you said, it's for microservices to run.
Yeah.
Where was it?
Yeah, the other, I see that this is, I think
No,
the root source.
slides. Go to the. Where is it? No, it's not here. Maybe.
Well,
Whatever. Okay. The thing is, I see definition that on Spinnakers here is more for Kubernetes, because Kubernetes can run microservices, but here it runs more advanced applications maybe than microservices, right?
Spinnaker is not running on
what is
Kubernetes.
VS Spinnakers in this
Yeah,
case?
Kubernetes is a cloud you're running.
Yeah.
And Spinnaker will integrate to it against it. So Spinnaker will orchestrate the deployments and this kind of stuff. So it will not run anything. It's just telling
So
Kubernetes what to run.
Run microservices, right?
Yeah.
As well. But this one runs pipeline too,
To control the clusters, yes.
right? Yeah.
So Spinnaker would launch the new generations of your services to Kubernetes, scale them up or down or whatever you want.
Yeah.
But it would not run them itself. Yeah.
I saw some crazy videos as well, like people on I forgot the name as well. What's it called? They build Kubernetes through Spinnakers as well. Like they run the whole the clusters of Kubernetes, and then you know what I mean.
Yeah, that's very possible. If you're running, let's say you're launching a Kubernetes cluster, you would, or if I was to run a Kubernetes cluster, I would create it with a pipeline, and I would deploy to it to AVS, and then I would make Spinnaker talk with the Kubernetes cluster running in AVS and deploy applications on top of Kubernetes. Yes. So it can handle all the layers. Yeah. Any more questions?
No? So, okay, that was good. I would say that we give a very big round of applause.
Thank you.